Here we have a problem on logarithm. Let's read the question. Find the number whose logarithm is minus 2.4678. So logarithm is found for some number and the result is received minus 2.4678. So we have to find the number for which logarithm is found. So we can assume x is the number, that is, let x be the number required. So logarithm is found for this x and the result is minus 2.4678. So now our target is to find the number, that is x. We have to find the value of x. Okay, so to get the value of x, what I am going to do is I am going to switch this logarithm to the right side of the equation. So when I move this logarithm to the right side of the equation, it will become anti-logarithm. So we get x is equal to anti-log of minus 2.4678. Okay, here we need to find the anti-logarithm of this number. Usually when we use anti-logarithm table to get value for a number, we will consider only the digits we have after the decimal point, not the digit we have before the decimal point. But in this case there is a negative sign in front of 2. So this negative sign is applicable for the whole number, that is for integer part and also for the fractional part. So here the fraction, we don't have to worry about this integer part because right now we are not going to include this integer part in calculation. So this will be included in calculation bit later. So when we use anti-logarithm table, we will be considering only the fractional part, I mean the digits we have after the decimal. But the negative is applicable for this for the digits we have after the decimal point also. Anti-logarithm table cannot be used for a negative number, it can be used only for a positive number. So we have trouble to use anti-logarithm table for this particular number because 4678 is negative. So now before we move to the anti-logarithm table, we have to make this fractional part, I mean the sign of the digits after the decimal point has to be positive. So to make the sign of the digits after the decimal point as positive, what I am going to do is I am going to make some changes in this number. That is, let me take a negative 2.4678. So now what I am going to do is, so now the problem what I have is, we have this negative sign applicable for the digits after the decimal point. So to make the digits after the decimal point a positive sign, I consider the integer which comes right after this 2.4678. Don't consider this negative sign now, just consider only the number 2.4678, and I am going to take the integer which comes right after 2.4678, that is 3. So now what I am going to do is I am going to subtract that integer 3 from this number. To adjust the subtraction, add the same integer 3 here. In the next step, I am writing both negative 3 and positive 3 in front. So I get negative 3, positive 3 minus 2.4678. Okay, so now what I need to do is I have to simplify this. That is positive 3, negative 2.4678. If I that is, I have to subtract 2.4678 from positive 3. So when I do such subtraction, I will be getting positive 0.5322. So now we have to write these two numbers together. How is it possible? So it's very simple. That is, negative 2.4678 is equal to bar 3.5322. So because I have written these two numbers together, how is it possible? This negative sign is applicable only for this 3, and for this fractional part 5322 we have positive sign. So in the same number we have to give negative sign for 3 and positive sign for the fractional part 5322. So that is what I have done here. So if I write bar at the top of the number 3, there is also negative minus sign, but this minus is applicable only for this 3, not for this number. So then what about these digits 5322? So the sign of these digits is positive. So the negative sign, the bar that we have at the top of 3 is a minus sign. That's applicable only for 3, not for this one. And here some students may get confused between this one and this one. So here we have minus, and I am saying the bar is also minus, but here on the left side in minus 2.4678, the minus is applicable for the whole number, for the integer part 2 and the fractional part 4678. For everything the minus is applicable. But on the right side, this bar is a minus, but this is applicable only for this 3, and for this fractional part 5322, so the sign is positive. So now x is equal to anti-log of instead of this minus 2.4678, we can take bar 3.5322, because both are equal. I mean minus 2.4678 bar 3.5322 are equal. So instead of minus 2.4678, we can write bar 3.5322. So now the digits we have after the decimal point are positive. So now we can use anti-logarithm table to get value for this number 5322. So because when we use anti-logarithm table, we will not consider the digit we have before the decimal point. So this will be included in calculation bit later. So now let's move to anti-logarithm table to get value for 5322. Okay, here we are going to look at value for the number 5322 in anti-logarithm table. So it's very simple. That is, we have to go to 53rd row, second column, and mean difference second column. Okay, first let's go to 53rd row. So this is 53rd row. Okay, now we have to take second column, that is here, and in mean difference also we have to take the second column, that is here. Okay, now let's mark the number. In 53rd row and second column we have 3404, and in mean difference the second column we have 2. We have value 2 corresponding to 53rd row. So 3404 and mean difference 2. Now we have to add them. Whenever we get a value from anti-logarithm table, we have to take decimal point after the first digit. So this is a value 3406 we have received from anti-logarithm table. So in this value we have to take decimal point after the first digit 3. So 3.406 is the value we have received for the number 5322. So not only for this particular value, for any value we get from anti-logarithm table, we have to take decimal point after the first digit. Okay, so now we got the value 3.406 in the anti-logarithm table for the number 5322. Okay, let's move to the previous page. So anti-logarithm of 5322 is 3.406, and always the value we get from anti-logarithm table to be multiplied by 10. And for this 10 we have to take the digit here before the decimal as exponent. So this is bar 3. Bar 3 is nothing but minus 3. This minus 3 should be taken as exponent for this 10. This is a procedure always we have to follow for the value we get from anti-logarithm table. So once we get a value from anti-logarithm table, it has to be multiplied by 10 for any value we get from anti-logarithm table, and for this 10 we have to take the digit before the decimal as exponent. So here we have bar 3 is the digit we have before the decimal, that is nothing but minus 3. Okay, now 10 power minus 3 is nothing but dividing by 1000. So whenever we multiply a number by 10 power minus 3, that is we divide a number by 1000, the decimal has to be moved to the left side 3 digit. But here we have only 1 digit, we need 2 more digits. For that I am adding 2 zeros. So we have decimal here. I am just moving this decimal 3 digits to the left. Then I will have point here. To make this point visible, I just take 1 0. So the required number is 0.003406. That is, logarithm is found for 0.003406, and the answer is received minus 2.4678.